Hi guys, hello everyone. This is Saurav here and welcome to the Vedantu VOS channel. This session is particularly important for kids who are preparing for the JEE Advanced, NEET, InChO, as well as any other state level entrance examination. We will be discussing today a very interesting topic in the topic of under the subset of isomerism, and that is tautomerism. Tautomerism, as you all know, is a very important feature observed within certain types of molecules, and tautomerism becomes the starting point of understanding the reactions of carbonyl compounds. So let's get started. Let's try to understand that what is tautomerism. So tautomerism is a type of structural isomerism which arises due to the change in position of H plus ion. If I were to write all the types of isomerism that we observe, so we can have we can divide it into two major categories. One is structural and one is stereo. Under the category of structural isomerism, we can have chain, position, ring chain, metamerism, we can also have functional isomerism, and then we can have tautomerism. Under the heading of stereoisomerism, we can have optical and geometrical. एक और सेट होता है जिसको हम बोल देते हैं कन्फर्मेशनल, which we'll not be discussing today. We'll be discussing about tautomerism. So tautomerism arises due to the change in position of hydrogen atom. ये change कैसे करता है? We'll observe it a bit in a moment. In fact, the structures which are generated as a result of tautomerism are known as tautomers, and these tautomers are in equilibrium with each other. So let's start with the idea कि भाई टॉटोमेरिज्म आप ऑब्जर्व कहाँ पे करोगे और किस तरह के सिस्टम्स में टॉटोमेरिज्म ऑब्जर्व करते हैं. So tautomerism is observed within something known as a dyad system and something which is known as a triad system. Okay, कहाँ पे हम ऑब्जर्व करते हैं? Dyad and triad system. So what is the dyad system? In a dyad system, we have a very unique example, that is of HCN. If the position of hydrogen atom, जो कि कार्बन के साथ लगा है, hydrogen is now present with carbon, if it changes its position and becomes something like this, then we will call it a dyad system. Okay, दो atoms के बीच में movement हो रही है from here to here. And if I take a triad system, in a triad system, we can represent a general formula as X double bond something like this. Sorry. So X डबल बॉन्ड Y Z H, और इसका जो टॉटोमर बनेगा वो आप कैसे बनाओगे? आपने इस हाइड्रोजन को उठा के X पे लेके आना है और इस डबल बॉन्ड को इधर शिफ्ट कर देना है. सो यू विल बी गेटिंग समथिंग लाइक दिस, Z डबल बॉन्ड Y X H. ओके, दिस इज अ ट्रायड सिस्टम. नाउ इसमें बनाने के लिए, if you want to draw this triad, the triad system is the most common one. You can see that it is, the hydrogen is moving from a given atom to the third atom. So in such as, if you want to draw the triad system, which is the most common one, you have to remember that X has to be oxygen or nitrogen atom, Y can be any atom, and Z needs to be sp3. अगर आपने ये वाले फॉर्म को लिया है तो इसमें ऐसा होना चाहिए रिलेशनशिप, एंड अगर आपने इस वाले फॉर्म को लिया है, देन इन दिस केस X has to be oxygen or nitrogen atom, Y has to be Y can be any atom, and Z will be sp2. So you have to be very very vigilant about कि आपको कौन सा सिस्टम दिया गया है, and within a given system what is the form given. जैसे कि अगर आपके पास ये वाला फॉर्म है ZHY double bond X, then you will be taking Z has to be sp3. In this form Z has to be sp2. Okay, now अगर हम इनके एग्जाम्पल्स डिस्कस करें कि टॉटोमेरिज्म कहां कहां पे ऑब्जर्व किया जाता है. ओके, if we observe where tautomerism is found, then we can give certain examples. For example, जैसे मैं एक ट्रायड सिस्टम का एग्जाम्पल लेता हूं, जैसे CH3 C डबल बॉन्ड OH. याद रखिए कि डायड सिस्टम का एक ही एग्जाम्पल है, बट ट्रायड सिस्टम कैन हैव मोर देन वन टाइप ऑफ एग्जाम्पल. सो दिस मॉलिक्यूल कैन बी रिप्रेजेंटेड इन दिस फैशन, CH2H C double bond OH. So this oxygen becomes X, this becomes Y, and this becomes Z. अब इसका टॉटोमर अगर आपने बनाना है, what you will do, you will just plainly move H from Z to X and move the double bond between Y and Z. So it will become something like this, CH2 double bond COH. ये हो गया आपका टॉटोमेरिक फॉर्म. नेक्स्ट एग्जाम्पल अगर मैं लूं, आई कैन टेक दिस. आप ये बोल सकते हो कि इस केस में कैसे हम डिसाइड करेंगे. सो इसको मैं X कर देता हूं, इसको Y, एंड दिस विल बिकम Z, एंड दिस विल ऑल्सो बिकम Z, because both of these are sp3 hybridized. Both of them can be utilized to perform tautomerism or to create tautomeric forms. So our structures will form like this. If you move a hydrogen from Z on the left, then you would be getting a tautomeric form like this. And if you move the hydrogen from right, then the tautomeric form will be this. Okay, these are the two tautomeric forms that you will observe. इन दो forms of tautomerism को हम बोलते हैं कीटो इनॉल tautomerism. We call it keto enol tautomerism because there is a keto group. Keto मतलब समझ लो कि C double bond O is being regarded as or being treated as a keto unit, and this becomes your keto, this is your keto, and this thing becomes enol. This is keto and this becomes enol. This becomes enol. Okay, what are some other examples of tautomerism? Tautomerism is observed in some other cases as well, so let's look at these examples. Next one is nitro-acinitro. नाइट्रो एसी नाइट्रो टॉटोमेरिज्म, एक नाइट्रो एल्केन आप उठाइए, CH3N डबल बॉन्ड O माइनस, दिस इज प्लस, तो देखो ये हो जाएगा X, this one will become X, this will become Y, this will become Z, and so your tautomeric form will be CH2 double bond N, oxygen with a negative charge, and there will be OH. So this becomes nitro nitro. The right structure is called nitro, the left one is called nitro. Okay. The next form is the enamine tautomerism. Enamine tautomerism. So how would I write that? CH3 C double bond N H CH3, this is imine, and enamine बनाने के लिए इसको आप ट्रीट कीजिए X की तरह, इसको ट्रीट कीजिए Z की तरह, and move a hydrogen to nitrogen and move the double bond between these two carbon atoms, you will get your enamine. Okay. Next, you can have amide imidol tautomerism. Amide imidol tautomerism. CH3 C double bond O and H2. Treat this as X. I'm sorry about this. Treat this as X and this as Z, and you will get CH3 COH double bond NH. This is imidol tautomerism or amide imidol tautomerism. Okay, and next one is nitrosooxime. नाइट्रोसोऑक्सीन. नाइट्रोसो कंपाउंड इस तरह से होते हैं N डबल बॉन्ड O, इसको X ले लीजिए, इसको Z. सो अब आपका टॉटोमेरिक फॉर्म कैसा बनेगा? CH2 डबल बॉन्ड N OH. इसको हम बोलते हैं ऑक्सीन. एंड द लास्ट वन इज एजोहाइड्राजोनो. हाइड्राजोनो टॉटोमेरिज्म. एजो ग्रुप कैसा दिखेगा आपको? N डबल बॉन्ड N CH H2 ऐसा ले लेते हैं. इसका टॉटोमेरिक फॉर्म कैसे बनाया जाएगा? लेट्स से दिस इज R. सो R, इसको ले लीजिए X, इसको ले लीजिए Y, इसको ले लीजिए Z, एंड सो यू विल बी गेटिंग NH N डबल बॉन्ड CH2. So there are 1 2 3 4 5 6, there are 6 categories of tautomerism. Remember that books में ये सारी categories नहीं दी रहती हैं. All of these categories are not mentioned in books. Books will only mention about keto, enol, nitrosooxime, azohydrazono. These things are not mentioned in books. Okay. Now the next thing that we need to understand is ki when we have identified that where would tautomerism be observed, let's take certain cases to identify whether tautomerism will take place in them or not. So मैं कुछ questions लेता हूँ. Let's try and understand that whether we would be observing tautomerism in these compounds or not. Okay. Next. So this is benzaldehyde. This is phenol. Okay. This. This. And let's take one more structure. Okay, we have to identify कि in which of these cases tautomerism can take place. So पहले तो हम ये identify कर लेते कि x कौन सा होगा. मान लो कि इसको मैंने x ले लिया और या फिर इसको x ले लिया. We do not have a Z atom which has a hydrogen. Z should be sp3 hybridized, and therefore this would not show tautomerism. There would not be any tautomeric form. Similarly, this will be x, this will be y. There is no Z atom which has a hydrogen attached to it, so over here also we will not be observing. In this case, if this is Z and this is y and this is x, so we have a Z double bond y XH kind of a system. हमें बनाना क्या है? ZH Y double bond Z system. That means this will show tautomerism, yes, and the tautomeric form will look like this. Okay. In this case, you have X, Y, Z. So this is amide imidol, HCOH double bond and H. This will be amide. This is an oxime. Oximes do show tautomerism. मैंने आपको पहले ही बताया है. देखिए, oxime nitroso. So we have to create a nitroso. So this hydrogen, if this is treated as X, this is treated as Y, this is treated as Z. So hydrogen has to go to Z. N double bond O. In this case, you cannot see a hydrogen just adjacent to X Y unit, but there is a hydrogen over here. इसमें tautomerism बिल्कुल होगा, because there is another rule set which says that if you have X double bond Y, A double bond B, a certain number of times ZH, then your tautomeric form will be XH, Y double bond A, single bond B, double bond Z, certain number of times. So इस हाइड्रोजन को हमें यहाँ लेके आना है. So this is of the type X double bond Y, A double bond B, ZH. So I'll get something like this. In this case, however, tautomerism would not take place because, I'm sorry, so if I place a hydrogen over here and let's put a double bond O over here, then tautomerism would not take place, because if this is X, this is Y, at the Z position, there is though a hydrogen atom, but this system is very unstable because of Brett's rule. Okay, violates Brett's rule. Now, what is Brett's rule? Brett's rule says that this is the bridgehead position. Bridgehead position would not try to acquire sp2 hybridization in a bicyclo system. Okay, so if you place a double bond, it will become very, very unstable. Okay. Next, how does tautomerism take place? So there are two proposals. In future, whatever tautomerism examples we will study will only be picking up the keto enol tautomerism, not any other tautomeric form, because those are the ones, like the keto enol tautomerism is the one which is most profound. So tautomerism mechanism, we have two types of mechanism. One is the acid catalyzed and one is the base catalyzed mechanism. Let's take a compound like this. I'm starting with the base catalyzed mechanism because it is the easiest and the most common one. Remember, all steps are in equilibrium. What will happen is it will abstract a proton from here, and we will be obtaining something like this. Now this will undergo resonance and the negative charge will delocalize to oxygen atom. And then it will react with H2O and release OH minus. We will obtain HCOH double bond CH2. This will be the base catalyzed mechanism. याद रखिए सारे steps equilibrium में है. In case of acid catalyzed mechanism, we observe a different take over here. So we start with this form, the keto form, and it is being treated with H plus. अभी H plus कहाँ जाएगा? So oxygen will take up this H plus. Okay, and then the compound which is formed, this ion which is formed, will react with H2O, where H2O will pick up this hydrogen. This will come over here and this will come over here. So 1, 2, 3. 1, 2 and 3 represent the steps in which the proton has been abstracted. We will be obtaining OH double bond CH2. So this will be our outcome. What we are getting is an enol. We are getting an enol, but the approaches are slightly different. In first case, we are taking OH minus. Over here we are not generating. Remember, in an acid catalyzed reaction, we would never observe a anion to be formed. Okay, is this clear? So remember, in a base catalyzed medium, an enolate is formed. This species is known as an enolate. Okay, this species is known as an enolate. Perfect. And if you take the acid catalyzed medium, remember that the first step is protonation of the carbonyl, and the next step is, so protonation of carbonyl, this becomes the slow step and this becomes the fast step of the reaction. In case of base catalyzed mechanism, again the first step is slow, the last step is fast. Okay, this is how the reaction takes place in an acid catalyzed and a base catalyzed medium. Remember that you would not be asked directly about the mechanism, you might be asked about how to create the entity. Let's take a compound to understand how this happens. So you react it with OH minus. OH minus क्या करेगा, नाइट्रोजन से प्रोटॉन ले लेगा and it will create something like this. This will come over here, this will come over here, this will come over here. 1, 2, 3. And you will get this O minus, which will further react with H2O to release OH minus, which was utilized. Catalyzed का मतलब whatever you are taking to perform the reaction, that needs to be removed, and you will get OH. Okay, so this is how tautomerism would take place. Understood? This is how tautomerism would take place. Now let's take another example. So what we would do is we'll react it with OH minus, we'll remove this proton, and we will form this species, O minus. This is an enolate ion, and then the negative charge will delocalize. And if the negative charge takes up a H plus, then we would obtain something like this. Okay, we'll obtain something like this. Let me show you a acid catalyzed mechanism. So let's say you have taken acetone, you react acetone with H plus, you will be getting CH3CO double bond O H CH3, and there will be a positive charge, and this will turn to become OH with a positive charge. H2O will remove this proton. This will go over here, and we will get a relevant enol. Okay. Now, the most important part of this chapter turns out to be this. How do you estimate the percentage of keto versus enol form? What is the method of doing that? Okay? So, there are in fact 7 or 8 ways to identify the percentage of keto versus enol. सबसे पहले तो आपको ये जानना होगा कि जो keto फॉर्म होता है ना, वो यूजुअली स्टेबल रहता है. ओके, keto form is usually stable, more stable than enol. Okay, ऐसा क्यों है? What is the reason for this? The reason is that if you take into consideration the bonds which are present in keto and which are being converted to enol, और इनकी bond energies अगर आप observe करते हैं, then you will find that the bond energy of all the bonds in keto is more than the bond energy of all the bonds in enol. Okay, so for example, you take this compound, इसका enolic form इस तरह का कुछ आएगा, CH2 double bond C OH. Now if I take the bond energy of bonds which are present in keto, and bond energies of bonds in enol, I'm only taking the bond energy of a bond. I'm not multiplying it with the number of times such a bond appears within the system, because that is not our job right now. So if I look at the bond energy of a CH bond and a CC bond and a C double bond O unit, because these are the bonds which will undergo the change. So this is 96 kilocalories per mole. C single bond C is 83 and C double bond O is 166. Whereas it changes to OH bond in enol, it changes to C double bond C in enol, and it changes to C single bond O in enol. O single bond H has a bond energy of 111. C double bond C has 145. And C single bond O has 80 kilocalories per mole of bond energy. इसको आप अगर ऐड कर दिए और इसको ऐड कर दिया आपने, you will find that the sum over here is more than the sum over here. So usually keto will be greater. ये मैं बोल रहा हूँ usually, okay? Usually the keto form will be greater. अब enol form कैसे increase कर जाएगा? If enol becomes aromatic after tautomerism, then percentage of enol will be very high. It will be very high. For example, अगर आपने लिया ये compound, this is keto, but its enol form is so stable that you do not even detect this. Okay, this is nearly 100%. This is the enol form, and it is nearly 100% because the ring has achieved aromaticity. So if the ring achieves aromaticity, then the enolic form will be more favored. Okay. Third, if enol becomes anti-aromatic, then only keto form exists. Okay, if it becomes anti-aromatic, for example, ये ले लिया मैंने, its enol form will be like this, double bond OH. Now this is anti-aromatic, and therefore this does not exist. This reaction does not take place. The percentage of this is nearly 100%. Okay, not nearly, exactly 100% keto. Okay. Next, fourth, if enol is created by abstracting H plus from bridgehead, position, then keto is 100%. Okay. The enol form of this would be written so this being the bridgehead position, this will not want to have a positive this will not want to acquire sp2 hybridization, therefore this process does not occur. The amount of this is 100%. इसमें इनॉल बनेगा ही नहीं, ठीक है, इसमें इनॉल बिल्कुल भी नहीं बनेगा. नेक्स्ट, okay. If branching increases at the position from where H plus is abstracted, then enol percentage increases. Increases due to hyperconjugation. Okay, due to hyperconjugation. For example, अगर आपने ले लिया CH3CHO and you compare it with MEC, ME, then the enol obtained from here, CH2 double bond C, OH, H, and the enol obtained from here, MECME, double bond C, OH, H. So this enol percentage will be greater than CH2 double bond CH, OH, H. इसमें ज़्यादा hyperconjugation रहेगा. There are 6 hyperconjugative forms, and there are 3 hyperconjugative forms. Therefore, the percentage of enol will increase. Okay. Next, if you are introducing aryl group at alpha position, if aryl groups are present at the carbon from where H plus is removed, enol percentage increases. मतलब the enol percentage in this compound will be way higher. In this case, will be way higher than the enol percentage that you observe for this compound. इसका reason क्या है? Because of this aromatic system. Remember that the compound is not becoming aromatic after tautomerism. The compound was already aromatic. So you can see that this double bond is now in conjugation. Conjugation makes things more stable, therefore the enol percentage in this entity will be pretty high. Okay. Next, if a group which shows plus R effect is attached to C double bond O, enol percentage decreases. Why? Because cross conjugation will take place. मान लीजिए ये ले लेते हैं आप. In this case, the enol percentage is way higher than the enol formed over here. The reason is there will be cross conjugation over here. So cross conjugation results in lowering the enol content. Okay, cross conjugation lowers the enol content. Perfect. एक सिंपल सा मैं आपको आइडिया भी दे देता हूं. मान लीजिए कि आपने ये कंपाउंड ले लिया, इसमें इनॉल परसेंटेज जो रहता है ना वो करीबन 76 रहता है. बट इफ यू टेक दिस, then the enol percentage is just 10. Okay, perfect. चलो एक दो और फैक्टर्स हम लेंगे. रिमेंबर बुक्स में इतने सारे फैक्टर्स दिए नहीं रहते हैं, सो लेट्स टेक टू मोर फैक्टर्स. वन फैक्टर इज नोन एज द एंट्रोपी फैक्टर. This factor is observed in open chain versus cyclic. So when you introduce a C double bond C in an open chain carbonyl, okay, introduction of C double bond C in open chain carbonyl reduces its conformational freedom. Okay, more than the reduction observed in cyclic. Clear? इससे होता क्या है कि जो when you are cyclic में आपके पास any process would want to go in a direction where entropy increases. अगर आपने entropy reduce कर दी तो enol percentage भी reduce कर जाएगा. Okay, and the last factor, the very last factor in this is the nature of solvent. इसको समझने के लिए we will have to consider the keto form and the enol form. In keto form, what you can see is that oxygen withdraws electrons towards itself. So the polarization of electrons is towards oxygen, and because polarization of sigma and pi is towards ऑक्सीजन। इसमें क्या होता है कि polarization of sigma is towards oxygen and pi electrons is towards carbon. Why? If I draw the resonating structure, you can see that the pi electron cloud has delocalized towards carbon, कुछ इस तरह का। So in this case, the dipole moment contributed due to sigma polarization and dipole moment due to pi polarization, pi electron polarization, is in the same direction. And over here, mu sigma and mu pi are opposite. सेम डायरेक्शन होने से क्या होता है कि पोलैरिटी इज हायर एंड ओवर हियर पोलैरिटी इज लोअर। इसका मतलब इफ द सॉल्वेंट इज ऑफ हायर पोलैरिटी, किसको वो फेवर करेगा? सो हायर पोलैरिटी सॉल्वेंट favors more polar species, that means keto, and low polarity solvent will favor enol. Understood? इसका मतलब हम ये ऑब्जर्व करते हैं कि इफ आई टेक एसीटोन इन हेक्सेन एंड इन वाटर, तो in hexane the enol form percentage will increase. It is in fact 92% and water में सिर्फ 15% रहता है, क्योंकि water तो इसको ऐसा समझना है कि the solvent which is more polar will favor the form which is more which has higher polarity, that means the keto form, like dissolves like, and solvent which has low polarity will favor that form which has low polarity or which is less polar. Okay, so these are the features for tautomerism, and tautomerism में different compounds के different extent of tautomerism enol percentage को identify करने के लिए we use these set of rules. So I hope you understood everything. In the next session we will start by taking some questions on these, and then we'll move on to some more interesting features in organic chemistry. Okay, so before let me just tell you about a bit about some important information. So टॉपर नोटिस बोर्ड विल गिव यू इंफॉर्मेशन अबाउट व्हाट आर द एंट्री पॉइंट्स और कैसे आप टॉपर बैचेस में आ सकते हैं वेदांतों के अंदर। एंड 2023 एस्पिरेंट शुड चेक दिस स्पेस as well as 2024. So this is Saurav Goswami signing off. I hope you enjoyed the topic tautomerism and we learnt some rule sets. Remember ये सारे rule sets एक standard book में नहीं दिए रहते हैं, तो इनको मैंने compile करके एक जगह पे रखा है और इसको आपको बताया. Please read about the or please try to apply these rules on questions of tautomerism in whichever book that you have, and let me know if you face any queries in the comment section. Okay, so that's all guys, bye bye and have a lovely time.